practice. Okay. So today we are going to learn how to calculate our sample size. Previously, we learned, uh, please give me some finish there. But, okay, so as I said, today we are going to learn how to calculate our sample size. Because previously we learned that it's from our population that we get our sample, and based on that, we can generalize for the whole population because dealing with the population is cumbersome and costly. Okay, so today we are going to learn how to calculate our sample size. Since, okay, so since we've learned some sampling techniques last time, we learned some sampling techniques. Okay, so we are going to learn how to calculate our sample size, and then from I sent this lecture notes for you some time ago. So I'm sure you've gone through this notes. So I'm going to summarize it. Okay. So for you to be able to calculate your sample size, okay, for you to be able to calculate your sample size, the first thing is to know your population size. And now you know that the population size is the total number of individuals in the sample. I mean, sorry, in the population. So if I'm to do something, let's say with regards to Garden City University students, then I have to know my population size. That's one part that you have to know. Before you can calculate your sample size, you have to know your population size. But it doesn't mean that always you have to know your population size. There are some scenarios or there are some research or situations that you may not even know your population size or that you don't get access to your population size. But when it happens like that, there's also a way of computing your sample size, which at the end of this lecture, we will know the differences. Okay. So first, you know your population size. Okay. And then secondly, you determine what we call the margin of error. The margin of error, or at times it's referred to as confidence interval. So the margin of error, you, the researcher, you are going to determine your margin of error. Nobody is going to, uh, I mean, tell you that use this margin of error. So you, the researcher, you will have to determine your margin of error. Okay. You will have to determine your margin of error. Let's say you are saying that I'm going to use 5% margin of error, 30% margin of error, 20, so on and so forth. So you are the researcher. You will determine your margin of error. Okay. So most cases, most researchers uses 5% margin of error, and that is 0.05. Most cases, they use 5% margin of error. So you, the researcher, you determine your margin of error pertaining to your research. Nobody will come and tell you that use this, that, but you have to justify why you are using your margin of error. So then the next is what we refer to as the confidence level. The confidence level. So with regards to the confidence level, you see, the confidence level works hand in hand with the confidence interval. You know, the confidence level. So the confidence level tells you how confident you are that the whatever you are going to compute or the sample size that you are going to get, you are confident that that will be a true reflection of the population with regards to this margin of error. Okay, so the confidence level tells you how confident that you are, or measures how confident that you are that whatever you compute will be a true reflection of the population. And so if you choose, let's say, 95% confidence level, okay, 95% confidence level, then you are sure that, oh, okay, I'm 95 confident that whatever I'm doing is going to be a true reflection of the population. But one thing is, the confidence level that you are going to choose will help you get what we call the Z score. In fact, it is not the confidence level that you are going to use to do your computations or your calculations. But, but, it is the confidence level that will help you get what we call the Z score or the Z score. Okay, so the Z score or the Z score depends on the what we call the confidence level. Okay, so if I'm doing a research, I want to compute my sample size, and I'm saying that I'm going to use a confidence level. Don't forget this confidence level, you, the researcher, you have to choose it. So if I'm saying that I'm going to use a confidence level of, let's say, 95%, then its respective Z score, because it is this score, this Z score, these are the scores. These are the ones that we use in your computation. But this score depends on the confidence level. Okay. This scores depends on the confidence level. If you don't choose these confidence levels, then you can't get your respective Z score. Okay. So if I'm doing a research and I'm saying I'm using a confidence level, 95% confidence level, 95%, then that means that the respective Z score will be 1.96. If I'm saying I'm using 90, the respective Z score is 1.65. And I'm using 99, the respective Z score is 2.58. 80 is 1.28, 85 is 1.44. But most cases in research, this is what we use, 95%. And then as you work with these confidence levels, the more you can record them, the more you can record them. As I speak to you now, I can record the 1995 and the 99, but the 85 and 80, because I don't use it more often, I can't record it unless I read it from a table. And don't bother yourself so much. All these Z scores, you can get it from a table, something we call the Z score table. You can get it online. So, for example, me, I don't bother my students so much with regards to memorizing this. But the more you work with this, you need not to visit the table. Me, for example, I can just say the 95% with its respective Z score by hand, just by heart. 1.96, 99 is 2.58, and then 90 is 1.65. Because I've been using it a lot. So the more you use it, the more you can recall. So don't think that it's something difficult or something you have to go and then do some rigorous computation here and then. No, 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 no. You can just pick it from a table. Okay. So the moment you get your Z score, okay, Deborah, please let me land, then you can ask your question. So the moment you get your Z score, there's another thing that you have to, fine, or go and get it. That's what we call the standard of deviation. The standard of deviation, okay, you specify your standard of deviation. Okay. So before I continue with the standard of deviation, I'm going to use this sketch to illustrate the relevance and the importance of selecting uh, a higher confidence interval. When you take an observation and you plot this sketch that you are seeing here, that's what we refer to as the normal distribution. The normal distribution. Okay. If you plot a lot of observation, that is how it behaves. So if I'm to select from that population, this is how they are behaving. And I'm using 99%. I am using 99% confidence level. you will see that that one, I'm able to cover almost all the individuals under the curve. You see that it covers almost all the individuals in here. Okay, it covers almost. So if someone is using 99%, then that means that the person is going to cover almost the individuals in there. That means that his sample is like it's very likely to be accurate as compared to that of the 99 point, I mean 95. These are 95 to we will cover that one. So if you compare 99 to 95, it's likely that the 99 will take more sample size than that of 95. And don't forget that your sample, the bigger or the larger it is, the better or the best. Okay, when your sample size is very big, that means that you are getting closer to the population, and that is best. Okay, so as it decreases, you see that we are only capturing a lesser part of the population. Okay, and so that is why it's advisable when you are doing health-related research. Some people are always asking you to go for either 99 or 95%. Okay, so that's it. So if you choose it, the 99, then that will give you 2.58. 95, that will give us 1.96. Okay. So if you are able to do that, then that shouldn't be a problem. The next thing that you need to know is what we refer to as the standard of deviation. The standard of deviation. This is not standard deviation. Standard of deviation. So the standard of deviation will tell you the number of individuals or the characteristics, how it deviates from each other, or how it is pertaining to that population. For example, let's say you are doing a research on the perception about biostatistics. So before you go in there, you will want to know those who are likely to, I mean, say no, and those who are likely to say yes. Okay, but that one is not, it's not easy knowing it before your research. It's not easy. It's not easy knowing your research. So what you have to do is you have to, I mean, to be on the safer side, you predetermine it. You have to split it. You just say, okay, then 50% are experiencing and 50% are not experiencing whatever I'm dealing with. Okay, so if another example, if you are concerned with, let's say, the rate of malaria in midwifery class, you will have to know the standard of deviation. You have to know the rate at which it's deviating, those who are experiencing and those who are not experiencing malaria. Okay. So that is what we refer to as the standard of deviation. So those who are experiencing that phenomenon, that is what we refer to as the standard. So most cases, researchers split it. To be on the safer side, they split it and say that those who are experiencing, which we normally represent as P, for those who are experiencing, we represent it as P, and those who are not experiencing, we also represent them as Q. And this Q is equal to 1 minus those who are experiencing, because if it's not white, it's black. So if we are saying that the probability that it is white is P, then probability that it's not going to be white will be 1 minus P, so that we can get Q. Okay, so the P here is always stand for those who are experiencing that phenomenon. And so those who are, let's say, with the malaria example that I cited, those we can say that this is for those who are experiencing the malaria, we represent them with P, and those who are not experiencing, we represent them with what? Q, or we can say 1 minus P. Okay, we can say that's 1 minus P. Those who are experiencing the phenomenon, we say that, oh, okay, those who are experiencing malaria in Garden City University, let's say they are just 60%. Then we can say that P is equal to 60%. 60% here is also, we can also write 60% as 0.6, okay? So that means that those who are experiencing the malaria in Garden City is what? 0.6. And then those who are not experiencing is equal to 1 minus P, and that is equal to what? 1 minus, the P is what? 0.6, 0.6. And that will give us what? 0.4. So it means that those who are not experiencing the malaria in Garden City University is just 40%. Okay, so we can say 1 minus P is 1 minus 0.6, which is equal to 0.4. And so that is the percentage of individuals who are not experiencing it. And so then that means that our P is what? 0.6, and 1 minus P is what? 0.4. Okay, so that is what we mean by the standard of deviation. So the standard of deviation means those who are experiencing that phenomenon and those who are not experiencing. And as I said, it's not easy to predefine that. If you are fortunate, let's say if you are fortunate that probably in a previous research, you are fortunate, probably in a previous research, if you are fortunate that in a previous research, someone did the work and then he has information that the rate of malaria in Garden City is 50%, or let's say 70%. We are fortunate that probably someone did the work some time ago, and then he found out that P, or the rate of malaria in Garden City, is 70%. 70%. Then it means that it is going to be 0.7. Okay. If you are fortunate and you have that, then you are good to go. You don't have any problem. You don't have any problem. You don't have any problem. Then you can go on and use the 0.7. Okay, you can go on and use the 0.7 because someone has already done this work, and then he has given us the information that P, which stands for the proportion or the percentage of individuals who are experiencing that phenomenon. Okay, the proportion or percentage of individuals that are experiencing that phenomenon. And then you can go and use that 0.7 and then Q, which is equal to 1 minus P. So for this case, this will be 1 minus 0.7, okay, 0.7. And that will give us what? 0.3, okay. So then for this research, your P will be 0.7 and your Q will be 0.3. Why using 0.7? Because someone has already done the work and given us that proportion of those who are experiencing that phenomenon or that illness or whatever. So we are fortunate, we are good to go. On the other hand, if you don't have any information about it, you don't have any prior knowledge about it, then to be on the safer side, you can just split it half. 50% are experiencing and 50% are not experiencing. Then you are good to go. You can now go and compute your sample size. Okay. Now let me take questions. Then we start with the computation. Okay, let me take questions and then we start with your computations. Okay. There was a hand up earlier, something Lumo. I think she's okay now. Okay, Sarah, ask your question.
Good afternoon, sir. Please, I wanted to ask if the Q is always one, and also if the population has to always be 0.5 for starting your research.
Population can
Thank
never
you.
ever be 0.5. Population, always you have to know your population size. It's your population size that you have to know. And Q can never ever be 1. You know what you have to notice when you add P and Q, the Q stand for those who are not experiencing. For example, we want to know the rate of, let's say, HIV in Garden City University. So the P stand for those who are having HIV. Okay. And Q stand for those who are not having HIV. And then if you add those who are having HIV and those who are not having HIV, you should get one. Okay. The P stand for those who are having, and the Q stand for those who are not having. If you add them, you should get what? 100%. If it is in percentage. If this is 60%, and that is also 40%, then the total should give us 100%. Okay. And don't forget these are probabilities. So instead of 60%, I can write it as 0.6. Okay. So if I'm saying that P plus Q should give us 1, then if I want Q, okay, change of subject. If I want Q, Q is equal to what? This thing will just come here. And once it's come here, the sign changes and it becomes 1 minus P. So that's why I'm saying that Q is equal to what? 1 minus P. So if I have P, if I have the value of P, I can subtract from 1 and get my Q. Okay. So that's why I made mention that it is 1 minus P. And this 1 minus P, the reason why I'm explaining this, we will need it in your computation. It is part of the formulas that we are going to use. I hope you are clear now. Millicent, ask your
Yes,
question.
sir.
Please, can you speak a bit louder?
Hello, sir. Hello, sir.
Yeah. Please talk.
Okay, sir, please, I'm confused about the whole thing. Please, I'm pleading with you if you can go over again.
Please, can you be specific with, because I started teaching population size. I've talked about confidence interval. I've talked about this. So can you be specific, please?
Hmm. Sir, about the whole issue, please, sir, from the start, please, because I
Please, can
couldn't.
you, which stat are you referring to? Is it from the sample, the population side?
Please, sir, if you can start all over again, please,
Wow. I've spent 20 minutes.
sir, please.
If I spend another 20 minutes going over again, that would be 40 minutes. So with regards to what we've done so far, we've not done any computation. Yeah, I'm just explaining the terms here. I want to, you see, the reason why I'm explaining these things is we are going to use formulas to calculate the sample size. And I want you to understand the figures or the letters in the formula. That's the reason why I've taken my time to explain these things. Okay. And then we've not done anything that is entailing or containing a lot of computations. Okay. It doesn't entail a lot of computation. Here, what I'm saying is you have to know your sample size. Okay. You have to know your population size. And how do you know your population size? You can only know your population size by counting them. So in real life, you just have to know your population size. So you have to understand what population size is. And I'm sure the population size, we've talked about this thing severally. So population size, you have to know your population size. That is the total number of individuals in the population. Okay. And then I made mention of margin of error. And I said the margin of error, you, the researcher, you have to set it on your own. So it is the error that you, the researcher, you are willing to make. Let's say whatever you are doing, you say, oh, I want to make, I'm making room for 10% margin of error. Or that means that whatever you are doing, uh, your likelihood of making an error is just 10%. So it means that the margin of error is now going to be 0.1 because 10% is 10 over 100. And 10 over 100 is like this. So this will cancel that, and this one will bring point here, and that will give us 0.1. Okay. And then the next thing is what I made mention of confidence level. The confidence level, as I said, tells you how confident you are that whatever you are doing it will be exactly as the true value. Okay. So, and I said that the confidence level will also give you what we call the Z-score. And I explained that the Z-score, you don't need to just go and do any computation. There are values there. There are values that has been computed and established. So if I'm using 95% confidence level, you, the researcher, you will choose it. Nobody will come and tell you to choose it. Okay. So 95% confidence level, the respective Z-score is 1.96. And if I'm using 99%, the respective Z-score is 2.58. Okay. And if I'm using 90, the respective Z-score is 1.64. Okay. So the moment you select your confidence level, then you can now move on to you go on because these are the figures that we will use for your computation. You are not going to use the 95%, and then you are not going to use the 99, so on and so forth. It is the Z-score that you are going to use. Okay. And then the last thing that I made mention of was the standard of deviation, and I've just explained that one. The standard of deviation, I just explained that it is the percentage of individuals that are experiencing and percentage of individuals that are not experiencing whatever you are dealing with. And the moment you add them, you should get what 100%. And 100% is the same thing as one. In probability, is the same thing as one. Okay. So that is it, my sister. I hope I've answered you. I said that the P stand for those experiencing it. And I cited that I'm doing a research, let's say the rate of I want to do something with regards to HIV. And then we said that those who are experiencing HIV, we represent it with P. And those who are not experiencing, we can represent it with Q. And then from change of subject, and then we know that P plus Q should give us 1 because percentage of those who are experiencing plus percentage of those who are not experiencing will give us what? 100%. Don't forget these things are in percentage or in decimals. So I just add them. That should give me 100% or 1. Okay. And so from change of subject, if I want P, it is equal to, if I want P, is equal to 1 minus what? This thing can go here. 1 minus Q. That will give me P. On the other hand, if I want Q, if I want Q, if I want Q, this is also equal to the P can also come here, and that will be 1 minus P. And I said that in a research, probably if you know P based on previous research, then you can just go and compute your Q. Then you can just go and use it in the formula. Okay. I hope I've answered you. Please, I'll plead with you guys that you follow what we are doing, please. I'm begging, please. Georgina Mrekuya, or what? Ajay. Georgina, I hope I've answered you right.
Sir, please, I wanted to ask if the P and then the Q, they are constant values or you are just using it for the illustration?
P are just letters. And I'm saying that P stands for those who are experiencing it, and Q stands for those who are not experiencing. So it's not a matter of constant, like a figure 3, 4, whatever. But I made mention that getting it in real life, getting it is it's not easy. So most researchers split it. Most researchers they split it as 0.5 and 0.5. Okay. But it doesn't necessarily mean that always 0.5 and 0.5. if someone has done the research and there's information available about the P, you can use it. Um, I'm sure
Okay,
Georgina
thank
is okay now. Deborah, ask your question.
you. Yeah, so if we add Q plus P, the one, can we say the one stands for the total population or the 100%?
Exactly. So
Okay.
100% means that you are done with the whole population.
Okay. And
Yeah.
then with the confidence level, you say we should not memorize the constants, which is the Z, how do we call
The
it?
Z
We should
score.
not
The Z score.
the Z score. In case in an exam you give a question related to that, are you going to give us the Z score you want us to use? Definitely, we are going to use
Um,
it for calculation, right?
for exam's sake, um, I may give it out, but the reason why I'm saying that I will not. The more you use it, the more you are able to recall. I didn't specifically tell you not to memorize it. I said that the more you use it, the more you are able to recall. And I said that don't bother yourself so much because in real life, I keep telling you that me, I don't teach for exam's sake. Okay. In real life, if you are doing your research and you want to calculate your sample size, if you go online research, you get these z-score values there for you. Okay. So if you don't understand it, that's where probably you find yourself wanting. So for exam's sake, I remember last time I gave them a formula and I think everything was in there. I hope I've answered you right.
Yes, sir.
Okay.
Thanks.
Okay. So now let's go and start with the computation. Please try and do it over there. Try get yourself calculators. I'll give you time to practice it. Try it over. So now let's go to the formulas. So the first formula is what we refer to as using the standard formula. This is what we call the standard formula. Okay. This is what we refer to as the standard formula. Okay. So this is the formula. This is the formula. I remember last semester I gave a list of formulas for them. So if for them to choose, so you will have to fish out the formula. So if you don't know that this is what I have to use, then it's up to you. Okay. So if you look at this formula, you will see that you will need to know your population size. You see N is in there. This is the formula. You see there's N here, which means that you have to know your population size. And then the z-score, you need your margin of error, and then you need your P, which is the standard of deviation. Okay, so this is the formula. The formula means that z-score, this is the z-score. Z-score square, this is square. And when we say square, it means that the number that is here multiply itself. Okay, so that means any number here will multiply itself. Okay, please, I'm advising you, do not think that you can put all these figures in the calculator and get your final answer. Mm-mm. There's no shortcut anywhere. Please, I'm begging you. Do it one after the other. Don't rush. Don't try to be a hero. Don't rush. Just take your time. If you get this in any exam, if you have to compute your sample size, do not rush. Take your time, one after the other. So any number here, you just multiply by itself. So for example, let's say I have, let's say I'm using 95%, then the z-score will be 1.96 squared. So this is equal to, this 1.96 squared is equal to the moment you see square, it means the number multiplies itself. So it's going to be 1.96 times 1.96. Okay. So whatever you get, you can write it here. Don't rush. Don't rush. Then you bring times. Then P. Let's assume that we don't have any prior knowledge about the P. So this time round, we are saying P is equal to 0. Let's use 0.5. Okay. So if P is 0.5, then this is going to be 0.5. Okay. Then into bracket 1 minus P, the same 0.5 comes here. So this one too, don't rush. Subtract your 0.5 from 1. Whatever you get, you put it here. Then you can now come and multiply the 0.5, the P here, by whatever you found in here. Okay? Don't rush. Please don't rush. Okay. Then you will see that at the end of the day, you get only two figures because you've multiplied this by that. And then now you can multiply everything here, the top, everything in there. Then you get a number. Okay, please don't rush. Now, the error, if it is 5%, then it means that it is 0.05. Don't forget a square. Once a square, you can now do what? It is the number multiplying itself. Okay, once a square, it is the number multiplying itself. So any number here, you multiply by itself. Whatever you get, you can now come and divide. And then that means that you are done with that side. That means that you are done with this side. Then you put that number there. Don't rush, please. Do not rush. Then you come here, you do the same thing. Do not rush. Multiply the number here by itself. You do your multiplications here. Okay. Then here too, the number multiplying by itself. And don't forget this N stands for the population size. Okay. The N stands for the population size. So then you can now multiply the down here. Then you can come and divide. And don't forget there's a 1 here too that you have to add. So when you solve all this side, you get a number. You already also have a number here. Then you can now divide to get your sample size. Okay. So there is an example here. I'm going to put it there. Those who are okay with it, please try it over there. Okay. I want you to try it. Try whilst I take questions. So this is the example. Okay. And these are the figures. I want you to try it. Okay. Please try it over there. When we finish, I'll put the final answer there and see those who get it. N is what? 425. That's why we have 425 here, because this is the formula. Let me minimize it so that you can see the formula. Okay. So you see the formula is here. Okay. Okay. So N is 425. This is 425. So that's why we have 425 here. So on and so forth. Okay. Please try it. Try it. I want you to try it. Do the computation there. Okay. There's a hand up. Whilst you try, let me take the question. So these things are formless. It's not a matter of, trying to conjure anything. Okay, Priscilla, ask your question.
Sir, please, I'm a little bit confused. Can you please go over the formulas again, please, once more?
Going over
Yes,
like
please.
please, what exactly do you want me to do? Oh, please, those
The
of you try
formula.
like explaining the letters or how to compute it. So I don't get it, please.
Yes, the whole show.
No, what's in India? What we are? And media CID.
Say,
Yes.
please, the whole show. I'm confused.
Oh, don't be confused. What I'm saying is, the formula is P. Where is it? Where is it? Here it is Z square, and then we know that the Z stand for the Z score. So if you look at this one, 2.58. You see, Z is 2.58. That means that, can someone tell me the confidence level here before I answer question? Can someone tell me the confidence level that we are using here? If you look at the Z score, what confidence level are we using here?
99.
Thank you very much. Thank you very much. Thank you very much. So it means that we are using 99% confidence level. And since we are using 99% confidence level, then the Z score for that is 2.58. So it's not a matter of any magic behind the Yakofa show. Times 0.5 is P. Okay? The 0.5 here stands for P. Into bracket 1 minus P. That's the same thing. And this 0.5, we didn't go and pick it anywhere. It has been given to us. Okay? It has been given to us from this question. P is what? 0.5. So that's why we have the 0.5 there. Okay? Now, the next one is the error. Because if you look at the formula, all these things are coming from the formula. Okay? Here too, the formula is E squared, and then E stands for the margin of error. What is the margin of error? 0.05. Okay? And then if you come to this side, it is 1 plus the Z. You see that the Z is here, 2.58 square. The square means that it is the number multiplying itself. Please. It is the number multiplying itself. Times here too, we have 0.5, which is the same thing as the P. 1 minus P. Okay? That is the formula. And then if you come downstairs, down this side, if you come here too, we have E square multiplying N, big N. And this E stands for the error. That's why we have 0.05 square multiplied by big N, which is 425. Okay? So that is, but your problem, you see, normally the problem that you encounter is your ability to point these things on calculator. Don't, as I said, take your time. Don't try to put everything in the calculator. If you do that, you may not get the right thing. So I advise you take your time one after the other. Okay. And so that's why I've taken my time to tell you that any number square means the number multiplying itself. Okay. Any number square means the number multiplying itself. So one after the other. This one, you subtract before you come and then do a multiply. So go and revisit your board math. Board math. Remember board math? But if you take your time and do it one after the other, there's no way you get it wrong. Square this. Square. Please square it. Please, if you finish, you can give me the answer. If you finish, you can give me the answer. Take your time. It's not 0.3. It's not 0.3. I think 3. Okay, I'll put the final answer there, then you check. Okay. Please, I hope I've answered you. Let me take the next question. Mariama Alhassan, please ask your question. Mariama, ask your question.
Sir, please, my problem is the queue.
The
Is the
queue?
queue constant? I don't understand.
Oh, but someone asked the same question and I answered her. But do you understand what the queue means? I told you guys
No,
that
please.
the queue. I, I told you guys that the queue stands for those who are not experiencing it. I told you that the queue stands for those who are not experiencing it. And so instead of writing Q in the formula, we don't have Q there. We have 1 minus P. The reason why I said Q is if you pick other books, if you go and read other books, instead of saying what seeing 1 minus P, you may see Q. Okay, you may see Q, but it's the same thing as 1 minus P.
Okay, sir. Thank you.
How please ask your question.
Sir, please, I want to know. So, in an examination, if a question is asked on a sample size, is the formula going to provide it for us, or you have
My
to?
sister, my sister, I told you me, I don't teach for exam. I've already informed you I don't teach for exam. And I told you guys that last year I provided the formulas for them, didn't I? No, that shouldn't be a problem for now. Please, I'm begging. Please, let's concentrate on the work now. When we are getting to exam, it's likely we will discuss how the exam will be. So please don't bother yourself on that. And now let's concentrate on the concept, how you get the understanding. That's the most important thing. Please, I'm begging. I hope I've answered you.
Yes, sir.
Adika Sarah, ask your question. Adika, I don't know if I
Sir,
mentioned. Yes,
sir, please, I want to know when you come down to the second part, we have 1 plus into bracket
okay.
2.58 squared. That one over there, is it constant?
Exactly. That one is
O-
constant. Because you can see,
Okay,
look at the formula, you see that that one is here.
okay,
You see? So that one is constant. That one is there. We are just
okay,
putting the figures in the formula.
okay, sir. Thank you.
That's fine. No, you're welcome. Please, have you finished? Adika, if you finish, you
Yes,
can you
sir.
can
Sir, I got 0.6.
no. That's not the answer. You made a mistake somewhere. Take your time. I'm sure your problem is how you got the square. You see, the problem is if you punch on your calculator 2.58 like this, 2.58 square like this, if you punch it like this, the calculator is going to square only this one, the number 8. So it's better if you are punching on the calculator, you have to, let me pick another color. I would advise you either go by this into bracket 2.58 like this, then you square it. That one, the calculator understand that you are squaring 2.58. Okay. And then another option is to be on the safer side. Another option. You can go by 2.58 times 2.58. That one too is also another option. That one is simple, which I prefer you use this one. Okay, so the moment you see any number square, you multiply the number by itself, and that one will help you. I'm sure that's why you guys are getting 0. I think the answer is you have put the answer there. Okay. Deborah, ask your question. Please make it brief, eh? So that we have to finish this slide today. Deborah, please ask your question.
Sir, please, the formula to, are we to memorize it?
You said?
Are we to memorize this formula?
Are you asking me that I read to memorize it?
Yes, are we to like have it,
My
are we
sister.
to have the
Okay, it's
formula
up to
up
you. That
there?
one I don't know. It's up to you if you want to memorize it. That one I can't tell if you have to memorize it. It's up to you.
Oh,
I've already told you guys that just get a concept. I don't know why you are so much concerned about the. I told you when it's getting to exam, you definitely know how the exam is likely to be. So why do you bother yourself so much with these things? Okay. The next Elsa, please ask your question. Ankuma,
Sir,
please
please,
ask your
what,
question.
sir, please, it wasn't a question. I wanted to say the answer, but
Oh, okay. Oh, don't worry. The answer I'll put it there in a jiffy, and then
okay.
you can see that.
All right.
Okay. Faustina, ask your question.
Please, I wanted to say the answer.
Okay, don't worry. I'll do that in a jiffy.
Okay.
Jemima, your question. Oh, Shunto, Jemima, your question. Okay, Hajara, Adam, ask your question.
Sir,
Yes,
please, with the 1 plus into brackets, the numbers, no. After calculating the one into bracket, no, do you remove the bracket and then you add it to the one, right?
exactly. The brackets there mean that whatever you have here, after calculating whatever you have here, then you can now come and add it to one.
To the one,
That's what it
okay.
means.
Thank you.
Okay, one Jemima is not talking. Please let me put there the answer. Please, if you get it, be honest with yourself. If you got it right or you get it right, please just type one for me, okay? Let me put the final answer there. I think it's okay, so that's the final answer. If you got it, if you get it, please, if you get it right or you are getting it right, please just type one for me. One. Just type one. One. Be honest with yourself. Oh, okay. That's fine. That's fine. People are getting it. That's fine. So you see, you take your time. That's the point. Don't be in a rush, one after the other. It's better to do whatever you can do perfectly than to be in a rush and finish the exam and go. But meanwhile, you've made a lot of mistakes. Okay. Now let me call.
Hello, sir.
Please let me call you before you talk. I'm begging. Okay. Jemima is not ready. Ado, Stevena, Aduchua.
Uh-huh.
Okay.
Sir, please, I had 259.4 and yours is
Oh,
0.39.
but
So
it's
I
the same
wanted
thing.
to know.
Yes, same
Okay.
thing, the same thing. I will advise you that you approximate it to the nearest whole number.
Okay.
That's it.
Thank you.
Priscilla, ask your question.
Hello, sir.
Yes.
Sir, please, the Z-score you gave us is 1.96.
No, I didn't give
But,
you 1.96, please. I
oh,
didn't give you 1.9. Look at the figures there. I even asked the class that what do you think this confidence
Yes,
interval
please.
is? And then
You
they
give me
said it's
that's what you gave me.
99.
Later on, you change your mind.
So I didn't hear you changing your mind.
Okay, no problem. Once you get a concept, it's okay. Personally, don't worry yourself so much. Once the concept is there, that means that if we change it to 1.96, you still get it. So don't worry, okay? Don't worry. Once the concept is there, it shouldn't be a problem. Okay, Gabby, Gloria, ask your question.
When I did it, I got 259.4076, but you got 39.
I said, don't worry with this one. The reason why you are getting 0.4, 0.3, 0.2, whatever, is because of the approximation. You know, when you are doing it, you approximate it. But you
Okay.
can see that the first three figures are the same.
Yes.
Don't worry yourself so much.
Okay, thank you.
That's why I said you can approximate the nearest whole number. But if you approximate the nearest whole number, you will still get the same thing. Okay, Florence, I'm going to ask a question. Then we move on.
Sir, please. I've seen two formulas. Are you supposed to use
Where?
the same thing for the same
Where?
side?
Two formulas,
The
where?
sample side.
The same thing.
One
It's
is
the same thing.
one formula is beginning with 1 plus into
No,
bracket
it's
that.
the same thing. It's the same thing. It is like this: A over B, okay, divided by D over E. So it's the same thing, okay? It's the same thing. We are not using two formulas, please.
Okay.
Okay, so now let's move on to the next formula, which I use most often and which is mostly used. Most cases, that's what we use. Now let's go to the next formula. There are three formulas that we are to do today. Okay. Most cases, this is what I use more of, I mean, most times or more often. This is what I use. And that is what is, most cases, people use this a lot because this one, you need not to know your population size. You don't need your population size. In most cases, we use this for a population which is very large, or probably we don't even know the population size. Okay, and this is also referred to as sampling based on proportion. That's what, there's another name for it, sampling based on proportion, percentage. So this one is very simple. So this one, all what you need is your z-score and then the standard of deviation and your margin of error. Okay, so you need your z, p, and error. Okay, this is very simple. And this is also more accurate or somehow better than the previous. Some argue that this is accurate than that one, and some also argue that the first one too is better than this. But I prefer this one. And then most cases, most researchers uses this one. So I want you to try your hand on this one also, and let's see the final answer that you get. So you see that this one, the z is equal to 1.65. So what do you think the confidence and level is? You can unmute yourself and talk.
90.
Exactly.
90.
Exactly.
90, please.
Exactly. Exactly. So try and compute the uh, sample size for this scenario. We have a z-score of 1.65, error of 0.03, and p of 0.5. Try and compute it. Compute it, and let's see whatever you get. Felicity, Edu, ask your question. Felicity, please ask your question. Oh, Ruth, a champion. Please, you are typing on my screen. You have to stop it. Try it. Try it. Please try it. Don't forget that we said that the confidence level, you, the researcher, you will choose it. You will choose your confidence level. And then the confidence level that you choose will call for the respective z-score. And so for this scenario, they've given us a z-score of 1.65. And that alone tells you that then the researcher chose 90% confidence level. So this z-score is related to 90% confidence level. So that's why we are using that. So please try it before try it. Those hands up. Go and try it before you ask your question. Okay, let me take the question for these three individuals. Then you go and ask your question. Felicity Edu, ask your question. Ask your question.
Please, I want to find out how you got the confidence level of 90.
Oh, that's what I just explained. Can someone help her? Can someone help her? She wants to know why we got a confidence level of 90 or why we are saying that it is 90%. Can someone tell her? You can just unmute yourself and talk if you want to help her out.
It is on the constant, the confidence level, that is the z-score, the table that he gave. It has a constant figure, which is the 90. The 90 has 1.65 as the z-score. That is why we are using that.
Okay, thank you very much. So as our sister said, the 1.65 is a constant value which comes from the z-score. So if you choose a 90% confidence level, its respective z-score is 90. And so when we started with the example, we saw that they've given us a z-score of 1.65. Then I asked the class, once we have 1.65, what do you think that the confidence level is? And the person said 90. And so that's why we are saying 90. I hope it's okay. Oh, I think I've covered the screen. Okay. Felicity, I hope you are okay now. Okay, Brida, ask your question. Yeah, people are getting it. 756. I think that's the right thing.
Sir,
Brida, ask your question.
yeah, sir, please, I want to find out if after getting the answer for the 1 minus 0.5, you have to multiply the first 0.5 by the 0.5 answer that you give. Or as long as
Exactly. That's what
you
it
have to
means.
multiply it.
Exactly. The moment you
Okay.
see a number A into bracket, let's say B, then it means that it is A times B.
Okay. Thank you, sir.
Okay. People are getting it. I thank God people are getting it. So if I give you something like this in the exams, will you guys be okay?
Yes, sir.
No,
Okay.
sir.
Yes, sir.
Yes,
No,
please.
sir.
Yes,
No,
sir.
sir.
Sir,
Yes,
this will be
sir.
better than the first one. We like
This
this
one
one.
is
Yes, sir.
wonderful.
This one is cool.
It's just going
This
First
is
one
forward,
is
better.
so
sir.
This is
easy.
better.
That's fine.
God bless you.
But it will not be like this. I'll put it in sentence. Then you have to fish out the P and then the E and then the Z.
No problem.
Then bring some of the sentence so
Thomas,
that
give us
you be familiar with it. Bring the
Then
scenario.
Sir, please, can we see the formula again? Scroll up so
the
that we see
formula
the
is on the
formula.
screen. The formula is on the screen.
Sir, can we see the way you
Sir,
did your calculation?
the way you did it
Please, I'm not
before,
seeing
sir.
the.
Oh, one at a time, please. Please, you can raise up your hand and then you talk, please. Someone requested for the formula. This is the formula. Okay, now let me put the final answer there so that you can check it out. Um, this is the final answer. So if you got it, please give me just type one for me. One. If you got it, type one for me.
What I think
Oh,
one.
that's fine. That's fine. That's fine. Good.
One.
Keep it up. Keep it up. Keep it up. Keep it up.
Hey,
That's fine.
no. One.
That's okay. The people are getting it right. Okay. So you see, you have to take your time. The problem is you don't have to rush. Take your time. Do it gradual, simple. You have to do things simple for yourselves. Don't rush, okay? Um, the next is what Rita do. Rita, ask your
Hello,
question.
sir. Sir, please, I'm a bit confused at this point when I'm computing it. Example with the one you just gave us right now with 0.03 uh raise the power to when I do it on my calculator, I'm getting exponents. I don't know why.
Oh, if I get the
Check your
exponents,
calculator.
and then
Check
it's this
your
one.
calculator.
What can I do? It's your calculator.
Mm-hmm.
Take your time
So
and then
then don't do it. Please, if you are getting it,
Raise the
let
part.
us
You just time
YS.
Who
0.03
is
times
that? What is she
0.03.
even saying?
this is what I don't like. Oh, someone is talking, another person is talking. If you continue like this, anyone who just comes in, I'll just put the person in the waiting room. Please, we are all learning, and then you see, just let people express themselves. Well, please, I'm begging you. So my sister Rita, you just have to
Sir.
take your time and
Okay,
then
sir.
try with other computers, other calculators. But if the exponent is let's say 10 to the power um, negative, is it negative
Yes,
or
it's
is
-4.
okay? So that means that you have to get four zeros in front of your number. That means you have 0 point other three
Zeros before the
zeros in
9.
front of the number. Yeah,
All right.
I think
Okay,
so.
sir. Thank you.
Oh, but you can also verify. You people, you just go and read it. This thing you can just even search. I don't know why you limit yourself to all nowadays. Anything you can search online and get information about it.
Okay.
Search. Okay, keep it
Hello,
up.
Thank
sir.
you.
Let's keep trying. Okay, just keep trying. Just keep trying, Rita.
Okay, sir. Thanks.
Okay, the next one, Charity and Co. Please give me some few minutes. I'll call you. So before I call Charity and Co., now let's look at the last formula, which is very
Yes.
simple, and that is what students normally use. Very simple. There's something we call Slovene's formula, Slovenes. But this one, you can see that you will need the population size before you can calculate it. This one is very simple, very simple. Okay, this one. So the N here stand for the population size, and we know this to be our margin of error. So I want you to try a hand on this. Try a hand on this. Because try a hand on this. This is the Slovenes formula. Try a hand on it.
Sir, please go back to the
Those,
formula. I was writing it.
oh, but please, I gave you the slides to you. I gave it to you about 2 weeks ago. So you should have it. Okay. Please try it. Try it. I'm giving you some few minutes. I'll permit you to ask your questions. Give me some few minutes. Hello? Sorry, I had to go to the washroom. Okay, so let me take the questions. Okay, let me put the final answer. This one that I believe God that everybody will get it. Did you all get this?
Yes, sir.
Good, 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 good. So, for example, I can say that um, as a member of a research group in a facility, you are to conduct a survey or a research on, let's say, HIV patients. Then I say you need to calculate your sample size. Okay. So as a researcher, you said that you are going to settle on 99% confidence level and a margin of error of 0.05. What will be the sample size that you recommend to your facility? Please, I hope you are getting the scenario.
Yes.
And so then that means that you will have to, you see that this time around, I mentioned the 99%, but I didn't say the Z-score. Do you get it?
Yes.
Okay. On the other hand, too, I can say instead of saying 99%, I can say that um, the researcher or the biostatistician mentioned that it is advisable to rely on a z-score of 2.58, a margin of error 0.02, in order to derive a sample size for the needed research or the sample size needed for the research. As a biostatistician in that facility, how will you compute your sample size? Okay, so this time around, then it means that you have to choose it. So you have to, once the researcher has made mention that he's using 2.58, an error of 0.05, and probably a proportion of, let's say, 0.5. Then you can just put it in. If someone is giving me feedback, you can just put it in, and then you get your sample size. Okay. So most cases, this is how I set the questions. Let me give another example. The last one, then I take the questions from you guys. Okay. As a member of Garden City University research team, you are tasked to conduct a research on the rate of diabetes among the Garden City University students. From previous work, it was identified that 80% of the students has diabetes. Okay. And as a researcher or a biostatistician in the team, you advise that you use z-scores 1.96 and 2.58. Again, as a biostatistician in the team, you advise that you use 1.96 and 2.58 with a margin of error 0.02 to derive your sample size. What is the sample size? And so you see that this scenario that I gave, I mentioned that from previous research, it was found out that 80% experience or were having diabetes. So it means that here our P is going to be what? 0.8. Agree? Do you agree with me? Okay, I think I muted all of you. Let me just unmute you guys. Do you agree with me? Now you can unmute yourselves.
Yes,
And then,
sir.
Yes,
Yes.
sir.
Yes.
and now I said that the Z-score, the biostatistician advised that you use 1.96
And
and I didn't say all and
Sir,
two.
please, the question again. No.
Oh,
oh,
I'm not computer.
okay.
We if you might be munaba. Why am I meant to the same thing? Oh, let me explain this. I think I can reframe it. You see, you remember I said that the researcher advised that you use 1.96 and 2.58 with a margin of error 0.02. So it means that here the researcher advised that you use 1.96 and 2.58. Okay. So it means that as a researcher, you have to use 1.96 to compute the sample and then also use 2.58 to compute the sample. And then at the end of the day, you just tell her the final one. And so it means that this question, it is 2 in 1. You need to do it 2 times. I hope you are getting the point. Because I said that the researcher advised that you use 1.96 and 2.58 with 0.0 to compute the sample size. And now he's asking about the sample. So once he advised 1.96 and 2.58 at the Z-score, then it means that you have to use 1.96 and 2.58. Okay. Or to be on the safer side, if probably the question was you can choose or you can choose from 1.96 and 2. That means you can choose one. Okay, so it depends on what the question tells you. And this is how I set, in most cases, I set my questions. You need to apply it. Okay. Okay, now let me take questions. Please, if you have any questions, you can raise your hand. You can raise your hand and I'll call you. Uh, then we can end the class. Okay. Please, any questions? Like, any questions? Vida, ask your question.
Sir, please, with the second formula, that you gave, I followed the formula though, but then I had 681. Is it because I changed the 009 and then I changed to 001? I don't get. Can you go back to the second
You
formula?
said you changed what?
The 2.7225 times 0.25 over 0.009. I changed the 9 to 1.
Oh, then it's oh. It's 0.9, then you've changed 0.1. Definitely you not get the same thing. Okay? Because they are
To
not the
the
same
nearest
thing.
digit, that is how I did it.
You
Okay.
said?
To the nearest like digit, 0.009, and I move the 9 to like 0.001.
Yeah,
That
even
was how
that,
come I had it.
even even
Uh-huh.
that, even
Okay.
that, even that, the differences shouldn't be so much because you are getting six something. I don't think that's the problem.
681.
No, 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 no. I don't think that's the problem. Probably there's also another place that you didn't compute it well.
Okay.
Because
All right.
even if you run into the nearest, decimal place,
Sure.
it shouldn't be the difference is too much.
Okay.
Please take your
Okay.
time and then recheck, and
All
then.
right. Thank you.
But once you get a concept, it's okay. So now you know the concept. Take your time, don't rush, please. I'm begging you. You
Oh,
don't take your time one after the other. And I would advise you guys that when you are working with this, you see that I have four decimal places. 1, 2, 3, 4. So it's advisable you work with four decimal places, and I'm sure you will not mix it out. Okay, so I'm done with her. The next one, Charity. Charity, please ask your question.
Hello, sir. Thank you. I was just
Please be
trying
brief.
to say that now, okay, and now next class, if you can bring sample questions like so that we will sort out the Z, the population size, and the margin score. It will help
Oh,
us understand it better.
that one shouldn't be a problem. There are a lot of questions online. If you explore, you get a lot of them. And the more you do that, the more you get these things. I don't forget that uh, I have others to also cover. So I'll see if I can do that next week. But if I don't, please you can search online how to calculate sample size using proportion, how to calculate sample size using Sloven's formula, how to calculate sample size using the standard formula. All these things you get a lot of questions online, and then you can explore that one too. Please, I hope I've answered you.
Yes, sir. Thank you.
But if God permits and I'm able to do what is expected of me, then go and then do a lot of these examples. So next week I will start with the hypothesis. God willing, next week I will start with the hypothesis. Okay, please. Next question. Haja, please ask your question. Make it.
Sir, sir, please, how many decimal places do you suggest we use? Like maybe four,
So I
three?
said I would advise you use four decimal places. If
Okay,
the question doesn't specify, just use four decimal places. That'll be fine.
okay. And with the final answer.
No, the same thing. If the question doesn't specify, four decimal places.
Okay, thank
But
you.
if it specify, you can stick to that one. But the final answer, when you are going to derive your sample size, I would advise you run it to the nearest whole number. The nearest whole number. Okay. What's next? What's next? What's next? What's next? I'm done. I just Ado, Stevana.
Hello, sir. Please, I
Yes,
wanted
Ado.
to know with the current scenario you gave with the two Z scores, after using the first one and then using the second one, are you leaving it like that or you add it and divide
Oh,
it
why should you
or
add it? No, this is different. That is different. So you can't add it. So
okay.
probably the next question is probably I may ask, let's say, um, what will you or what sample size will you settle on? And probably I may ask why. What sample size will you settle? So if I ask what sample size will you settle on, then you have to go for the one calling for the huge number, or that means the one taking the largest sample size. Because we know that the more your sample size is big or large or huge, then the likely or how good or how perfect it reflects the population. That one I've already mentioned it. When the sample size is large, then that means you are good to go. So we always go for a larger sample size.
Okay, sir, thank you.
Okay, so now Gloria, Gabby, ask your question. Gloria, Gabby.
So, Miss, my question is also about the one you did with the two different scores.
So I've answered
Are
you,
we
right?
solving it? Pardon?
Okay, I thought I've answered you.
Are we solving it simultaneously or like individually?
Oh, the same thing. You do this differently and do that one differently.
Okay.
Benny's prefer.
Sir, please, with the scenario that you just gave, the population size wasn't given, so it means you can only use the second formula. Or
Exactly. So these are some of the things that
okay,
when you work, you know. Exactly. That means you can't use the first and then the last formula. Well, those ones you can only use it when you know the population size. Do you get it?
okay. Thank you,
Thank you.
sir. Yes, sir.
Um, Freeman cancer.
Yes, please. Please, I want to know the
Please,
answer
what's the
for
other
the
name?
test.
Can you mention the other name for me?
Jochebed.
Jochi bed.
Yes.
Not Joki bed.
Yeah, you can also pronounce it as Jochebed.
So which one do you prefer?
Any, any is fine.
Okay. Okay, Jochi,
So
Jochi.
please,
Talk to us.
please, my question is, I want to know the final answer for the third question you made us try on. My network went off, so I didn't
Oh, I
see.
think the final answer was 173.41. This, are you referring to this? The one on your
Yes, please.
screen? Okay.
Yes, please. So please, if you have other two numbers, because mine I have 04 at the end. Is it correct?
Yours is 173 what?
1734104.
Oh, this is correct. It's the same thing.
Okay, thank you.
Esther, ask your question. The last person for the day. Esther. Mama Esther, ask your question. Okay, Mama Esther is not talking. So please, take your time, try get other questions, revise on this, and then
Say,
go. Okay, Esther, now talk.
I said I was having problem with the last question. Yeah, I was having difficulties in my network, so I couldn't join that one. So kindly help me.
Please, can you be specific what we have to do for you?
So I think the last question you gave the population size and you
Mm-hmm.
gave the 240 and those things. The population size, the error. I need to help me calculate that one because
Which
I didn't
one?
get.
This one, the one on your screen right now. Please, are you referring to the one on your screen right now?
Please.
Hello?
Yes, say.
Uh-huh.
I'm referring to the one.
Salome Apia Nkrumah. The next time you do that, I may probably let you give the class. So, please, you are referring to the one on the screen right now. Esther, please unmute yourself and talk.
Sir, please, I'm talking about the one on the screen right now.
Okay. Oh, but that one, this one, I didn't calculate it. Your mates did it too.
And so help me out because I couldn't get it. Thanks. The network is, I'm having problem with my network.
So sorry, the network just went off. So saying you have to know your population size. So that is your
Network and the any crowd.
the network is becoming unstable here. So Esther, please, I hope you're okay, Esther.
Say, I couldn't hear anything. No, the network. I couldn't hear anything.
Minutes. Esther, what I said was that this thing is a formula. So you need to just fish out the values in the formula, then you just put it in there. The rest is just calculator work. You see, here, that is the formula. Okay, this is the
Yes.
formula. So once you have this formula, and this is the example, these are the values. N stand for the population size, E stand for the error, 1 plus that. Okay. So we just place the values in there. Esther, I hope this should be okay for you. Okay.
Yes. Thank you.
Okay. Okay, so I'm going to end the class, and God willing, we meet next week. Okay. So I'm going to take the last from these two guys and I'll end the class. I'm not taking any other because it's almost time. I just have 5 minutes. Okay, Stella Amufa, ask your question.
Okay, sir, please, I want to ask, would the question determine the kind of formula you use? Or you can choose to use any kind of formula for the sample size because I wasn't able to participate in the first and second formula.
It depends. It depends on the question. So if the question asks you to use, let's say, Sloven's formula, then you have to use it. If the question asks you to use, let's say, sample based on proportion, you have to use it. Okay, so it depends on the scenario. It depends on the scenario.
Okay.
If it doesn't
Okay.
specify,
Thank you.
if it doesn't specify, you have the liberty to choose any of this,
Okay.
depending on the parameters there or depending on the values there. Okay, so it depends on
Okay.
what you get. Okay,
Okay, thank
so
you.
so see you guys next week. Please take care of yourselves and God be with us all. So God willing, we meet next week. I love you guys. Bye-bye.
Bye.
Bye-bye.
Bye.
Bye. Thank you.
That's it.
Bye.
We
Bye.
love you too.
God bless you.